Hi guys, Dr. B here. This is a lecture for formation of how to form ionic compounds. So the first thing you need to know is the oxidation number. It's the state of an element or an ion in a compound with regard to the electrons gained or lost by it, and it forms a positive or negative number based on if it loses or gains electrons, which we've discussed and discovered in class actually. So excuse me. So this is basically the number of electrons either lost or gained by an atom when it follows the octet rule. So when you look at the periodic table, which you should have already, and you see how many electrons it gains or loses for it to have a full valence shell, whether it's a full octet or not. So magnesium, when you look at your periodic table, in order for it to behave like neon, it will lose 2 electrons. So by losing 2 electrons, its oxidation number will be, oops, my Lord in heaven. Its oxidation number will be 2 plus because you have more protons than electrons. So by having more protons, you have a plus charge. Chlorine, it will gain 1 electron to behave like argon. So it will have a 1 minus charge because it has 1 extra electron than the original. Potassium will lose 1 electron to behave like argon. So its oxidation number is 1 plus. So were some exceptions to the rule that we need to think about. So into the octet rule, so to speak. So certain elements like hydrogen, helium, lithium, beryllium, and boron cannot gain or lose electrons to have a full octet, but they'll have a full valence shell if you lose or gain electrons. Transition metals also don't need to have a full octet because they have that weird d orbital, all that type of stuff. So these things right here you don't need to really write down, but you need to pay attention for now. So you have sodium and chlorine reacting together to form sodium chloride. So what happens is when chlorine will gain an electron and sodium will lose an electron, they form opposite charges. These opposite charges, meaning the plus and the minus, they interact with each other, and this is called an electrostatic attraction. This electrostatic attraction is what is responsible for creating a crystal lattice structure with these ionic compounds. So what's happening is that sodium will lose, there's also supposed to be arrows by the way. Sodium will lose an electron like we've said. It behaves like neon. Chlorine will gain an electron to fulfill its full octet rule and forms a chloride ion, so it behaves like argon. So combining both of them, what you end up with are essentially 2 noble gas configurations because they lost and gained electrons to interact with each other. The opposite charges on those ions, plus and minus, is the electrostatic attraction that's responsible for them interacting with each other to form the stable compound that it is. So metals will lose electrons to form cations depending on how many it needs to fulfill its full valence shell. And nonmetals will gain electrons to get its full valence shell to behave like a noble gas. So all of these elements, what they are doing is they are trying to get a full octet. Kind of jumped ahead, my bad. So some exceptions, like I said, to full octet in the valence shell: hydrogen, helium, lithium, boron, and beryllium, and transition metals. So we're gonna work through this through 2 different methods. So it's going to be something called a Lewis dot structure and a crisscross method. So you have to know your oxidation numbers quickly, as well as your Lewis dot structures. So we'll do both to make sure we understand what we're doing, right? Sorry, my phone went off. Oh, excuse me. So magnesium and fluorine react to form magnesium fluoride. We'll do two different methods. The first one will be the Lewis dot structure method, and the other will be the crisscross method. I'm pretty sure I said that already, my bad. So it's based on a, let's see, so magnesium has two dots on its Lewis dot structure. Fluorine has a total of, different color. Nice, you can really see this one. So fluorine is more electronegative than magnesium, so it's going to steal one of its electrons. It goes over here. The thing is now is that fluorine has a full valence shell because it has a total of 8 valence electrons. So now its electrical charge is 1 minus. However, fluorine has still that dangling electron over here I'm circling sort of. So it needs another fluorine to steal another electron. And in doing so, magnesium now has no more valence electrons to work with. So because it lost 2 electrons, its overall charge is 2 plus. A question you had on your lab, what is the overall charge for like a compound like this? It would be neutral because you have a 2 plus charge and 2 1 minuses. You put them together, you end up with 0. So the formula, the pattern is cation and anion. So the formula is going to be MgF2 because there's 2 F's. So let's try the oxidation number method. So magnesium is a 2 plus ion, and fluorine is a 1 minus ion. When you're doing this, you would just drop your letters, the symbols, in the same order, and you're going to crisscross just your numbers. You leave the symbols alone. There are no plus or minuses in a formula. So if I bring down this 1 and this 2, that's fine. But in reality, if there's already a symbol, it implies that that the element's already present. So it's just MgF2. Your formulas should be the same if you were to do both. If you end up with different ones, don't do that. Magnesium and sulfur react to form magnesium sulfides. We'll do the same thing that we did. So magnesium has 2 dots. Sulfur has a total of 6. Sulfur is more electronegative, so it's going to steal one of these electrons, I'm sorry. Sulfur has a total of, including that red one there, it has a total of 7, so it's going to steal another one over here. Now, this sulfur has a total, let me see if I can just make them look different. So these right here are the valence electrons it has now in the end. So it's a total of 8. So it gained 2 electrons, so its overall charge is now, its charge is 2 minus. Magnesium lost 2 electrons, so it's 2 plus. You have one of each element, so you just Mgs. That's it. You have Mg 2 plus, sulfur 2 minus. That's the oxidation numbers you get from looking at the periodic table. So you just drop your elements, and now you see I want to crisscross my 2 from the S and my 2 from the magnesium. These 2 2's that you brought down crisscrossed, you can reduce those numbers. So the final answer is MgS. Remember, to reduce means to divide by the same number, and you end up with whole numbers for both. Hopefully that math language means the same thing, or that sounds familiar. I'm sorry. So what do you notice about the naming scheme? The metal and the non-metal. Metal comes first. The metal comes first, then the non-metal. The metal's name stays the same. The non-metal gets a suffix change. So you should have a list on Google Classroom. It's a list of the suffix changes. So it's essentially you replace the ending with "-ide", but some letters get removed like from phosphorus becomes phosphide, sulfur becomes sulfide, but then oxygen becomes oxide, or fluorine becomes fluoride. Some are easy. You just have to know those because I give you the spelling, so spelling counts, obviously. Duh. So anyway, moving on. So let's try sodium and phosphorus. So sodium is Na, phosphorus is P. Phosphorus has a total of 5 valence electrons. Sodium has 1. Phosphorus is more electronegative, so it's going to steal that electron. I have no more to work with from that sodium, so it's 1 plus. But I'm going to recruit more sodiums so I can steal those electrons until my phosphorus will have a full valence shell. My phosphorus gained 3 electrons, so its oxidation number is 3 minus. Now for my final formula, I have 3 NAs and then 1 P. The name for this one should be sodium phosphide. Oxidation number method, sodium is 1 plus, phosphorus is 3 minus. Didn't mean to do that actually. And then I'll do this color for this. That's what I want to do. So I'm going to drop the NAP. I bring the 3, crisscross that, 3 over here. Right, if you crisscross a 1 and bring it down, you don't need to put it down per se, but you have to be mindful that it's there, that there's 1 P there. Final answer is Na3P. Yeah, looks like the Grinch colors. Funny. Lithium and oxygen, LDS, oxidation number method, crisscross method. Lithium is 1 dot, oxygen is a total of 6. It is going to steal 1 dot. Oxygen has 7 valence electrons now, so I need a second lithium to steal that one. Luckily, my oxygen now has a total of 8 valence electrons. It gained 2, so it's a 2 minus oxidation number. Lithium is 1 plus because it lost 1 electron each. And your final answer is going to be Li2O. The name is lithium oxide. Oops. The oxidation numbers, so we kind of see from there, but lithium is 1 plus. Am I doing? Oxygen is 2 minus. So LiO, I crisscross the 2 over. The 1 is fine, so it's lithium oxide, Li2O. Work backwards to figure out the names of the following. So if I give you an ionic formula, you have to be able to give me the name. If I give you a name, you have to get the ionic formula. If I gave you just the ions, you have to give me the formula and the name. So it's crazy, huh? So you have to recognize what is present. So you have a K and a Cl. So this is just potassium chloride. Oops, chloride, my bad. This is S and Br2. So strontium bromide. There are no prefixes in an ionic name. What I mean by prefixes, I mean like di, tri, tetra, penta, hexa, hepta, octa, nona, deca, mono, all that type of stuff. Okay, so to figure out, you notice here there's there's an FeS and an FeS here, but Fe2S3. Anyway, so there's 2 different types of iron, so you have to figure out which one is the correct one based on what ions contribute to their oxidation number. So let's see if we can figure that out. So this we know that sulfur, I'm going to put this to the side so it just kind of stands out. Sulfur is automatically 2 minus. So I'm going to work on this first one here. So if this sulfur is 2 minus, and you'll notice that this iron in this FES, you'll notice that if the 2 crisscross from the S to the Fe, there'd be a 2 on the bottom. But because there's no 2 there, that means the iron was originally 2 plus. Because when you crisscross the 2's, you can reduce them down 1 to 1. So the name is iron 2 sulfide. Similarly, you do the same thing for the next one. So S is 2 minus, Fe, you can see that this 3 came from that iron. So it's actually iron 3 sulfide. So when we look at these last two examples, we had transition metals. So you got to still be able to do oxidation number method and crisscross method for this. Oh, sorry, and Lewis dot structure method, my bad. So the oxidation number method, so you look at here, this is iron with a Roman numeral 2, so it's actually Fe2 plus. That's where that comes from. Cl1 minus. I crisscross the 1 and 2. I don't know why I did it like that. That's kind of bad, actually. Nice, 1 minus. So I'll make this 2 in red, and yellow is this 1. Oh, this must be yellow. But so Fe anyway, let's try it again. FeCl. So the 1 from here goes down to here, and this 2, oh my god, there it is. FeCl2. Same thing here, Lewis dot structure method. So the iron 2 plus, knowing that means the iron originally had 2 valence electrons. Chlorine is Cl, 7 valence electrons. It is going to steal one of these valence electrons. Now it is a 1 minus oxidation number because it gained 1 electron to have its full valence shell. I still have this extra one here, so I need a second chlorine to steal a valence electron. It's a 1 minus charge. Fe lost 2 electrons, so it's a 2 plus charge. So you just follow your pattern. Cation is Fe. There's 1 of them. You have 2 Cls. Do not combine the Lewis dot and crisscross method because that's really wrong. So please don't do that. Okay, thanks. So we did ionic, now it's polyatomic compounds and polyatomic ions. A polyatomic ion is just a really large ionic compound, meaning you still have positive and negative charges, but you just have more elements involved. So definition. A polyatomic ion technically is an ion that contains 2 or more atoms chemically bound together in a single unit that bears an electrical charge. Positive or negative, but mostly negative. There's 1 positive, and it's called ammonium NH4 1+. There is a whole list for you to know, not memorize, but know because, hey, I'm going to give you that list, so that means spelling counts, guys. You only do the crisscross method for these, luckily, so if I give you a question and I give you the formula, I'm sorry, you give up the name, you have to figure out the formula based on what's present. So this is sodium, Na1+. A perchlorate ion is Cl04 1-. Luckily, we are crisscrossing 1s. So all you need to do is kind of drop your elements, compounds, ions, whatever you want to say, and make sure that it's following the lettering, capital, lowercase stuff, but you're good to go. Next is calcium phosphate. So I'll make this one more legible. Calcium is 2+. Phosphate is PO4 3-. Make that one blue, this one orange. You drop your elements, ions, in the same position, same order, I mean. You bring down this 3 from the phosphate to next to the calcium, and you bring down this 2 over here. Oop, my bad. This 2 here. But this isn't bad form. So what you need to do is actually put a pair of parentheses around your ion for it to make sense. So the idea is that you have 3 calcium ions and 2 phosphate ions to balance out to make an overall neutral compound or zero charge. Iron 2 sulfate. Hope I have enough space for this guy. See, iron 2, that's Fe2+. Sulfite is SO3 2-. I'll try to use the same type of thing here. So Fe and SO3 drop down. I'm crisscrossing 2's actually. So luckily for us, we have the same thing. Meaning that the formula is just FeSO3 because the 2 oxidation numbers are both 2. So lucky us. Well, ignore this part up here. That's the next slide. Don't know what happened. Anyway, so make the ionic compound magnesium oxide. We're going to do oxidation number method, Lewis dot structure method, oxidation, Lewis dot, oxidation, and oxidation. So magnesium oxide, Mg is 2+, O is 2-. You crisscross the 2's, you end up with just MgO. Lewis dot structure method, lithium is 1 dot, chlorine is a total of 7. Lithium is going to steal this 1 electron. Chlorine is now 1- because it gained 1. It has a full valence shell. Lithium lost 1 electron, so it's a 1+, so you end up with just LiCl. This right here is not the formula. When you do a formula, there are no symbols, no plus or minus, and the numbers, if there are any, are all subscript, meaning they're below the line. Let's try oxidation number oxidation number method for Fe2 and oxygen. So Fe2+, O2-. So you crisscross the 2's, and what you end up getting is something really, really ugly. Because it's feo, muy feo, ugly, all that type of stuff. So the name is iron 2 oxide. Iron 2 oxide. So you have iron 3+ and fluorine, Lewis dot structure method. Hopefully I have enough space. Anyway, so iron it's a 3+, so it means that it lost 3 electrons. Fluorine is 7 valence electrons. That's ugly. Anyway, fluorine is really electronegative, so it's going to steal this 1 valence electron. It now has an oxidation number of 1- because it already has a full valence shell and it gained 1 electron to obtain that. You have 2 other electrons, so you have to recruit more fluorines to take those, to get rid of those off that iron. So we're going to steal this. Fluorine is a 1- charge. This iron is 3+ because it lost 3 electrons to obtain its full valence shell. Or for it to be, yeah. So then you end up with Fe and 3 Fs. The name is iron 3 fluoride. I'm going to try this color. So sodium is Na+, a carbonate ion is CO3 2-. You crisscross your 2 and the 1 from the sodium, so you end up with just Na2CO3. 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 Potassium sulfate. You have K1+, sulfate is SO4 2-. You crisscross the 2 and the 1, You end up with K2SO4. Do not reduce that 4 from the O. If the 4 is below and it's connected to an element like this, like that, it does not get reduced. So beware that temptation. Examples on how to figure out the name based on the formula. So we have a potassium here, and recognize that this polyatomic ion is chlorate. So the name is potassium chlorate. Oops. This is Sr, strontium, and this is CO3. That right there is carbonate, so the name is strontium carbonate. So here we have copper. This right here is CrO4. So recognizing that, gentlemen, a chromate ion is CrO4 2-. So if you're dealing with a transition metal, you have to be able to recognize what ions are present as well as its oxidation number, because that will tell you what type of copper or iron you're working with. So you'll notice that this 4 comes from the CrO. That's CrO4, that's that. So its oxidation number is 2-. Copper, if this 2 is here and it would cross down to this spot, and there's no other number here, this 4 is from the O, from the chromate, so it's Cu2+. That means that this is originally copper 2 chromate. All right, that was a lot, I know. So, a lot of things to think about, to work on. So, if you have any questions, gentlemen, if you have any questions, please let me know. All right, thanks. Bye. This is the way.